thing, and when the button is clicked, or when the mouse is clicked anywhere in the window here, have it do the lock cursor then, and then everything will work the way that you intend it to. This is only a sort of funny behavior that happens inside the editor. It's not a problem in a standalone game. And it goes away completely if you start the game from a main menu. For example, if there's a menu, a title screen, and it says click here to start, and you click there, and then it does the mouse lock, you're never going to have a problem at all. So this is just something like, I remember like experiencing it for the first time, and just like my mind is exploding, like, why is this mouse cursor behaving so oddly? And it turns out it's just a quirk of the editor. And it goes away if you're maximized. So today I learned. And if you want to know, like, how do I get my mouse back so I can do stuff, just hit escape, and then you get your mouse unlocked. And again, that's a function that just exists in the editor itself. In the standalone game, escape does not automatically unlock the mouse cursor. So if escape is supposed to bring up a menu in your game, you're going to have to unlock the mouse at that point. All right, so I just hit space because I like to jump in games, and I noticed that I'm currently not jumping. So we're going to look at vertical movement next. 50 Shades of Predetermined Gray Light. Yeah, nice. It is a very gray world, and I mean, we could color it up. Again, I'm not going to deal with texturing too much. We're gonna look into some more fancy lighting at some point, but we're gonna worry about that next, or not next, but we're gonna worry about it a little later. First thing I want to do is look at jumping, and unfortunately, that means no longer being able to use our simple move command. Simple move is great in that you just feed it some speed. I want to go at this speed. And it says, okay, I'll deal with it. I will figure out what the frame rate is. I will make it so that you're moving, at the same rate no matter how many frames per second you're operating at. It's going to be fantastic. It also takes care of gravity for you. If let's take my guy here, my player, and we're gonna set him. We're gonna set him 20 units above the world. And then when I hit play, I'm gonna fall, thump, and land in the game world. Awesome. Simple move handles the gravity for you, and so everything seems to be great. The problem is it handles the gravity in the sort of vertical movement because it ignores any y component of your speed. For example, if I fed in here, I want to be moving upwards at 100 meters per second, and then I hit play, it's going to ignore that completely. It's just going to drop us to the ground, and that's it. How dull. So if you want to make a person that can actually jump up and down, or you want to have any sort of a flight mode, you want to have a mode where your guy ignores gravity, you want to do anything like that, maybe gets knocked up in the air by explosion, you can't use simple move. It does great for what it's supposed to do, but there's sort of a limit. So instead we're going to switch to move. Now move is different in that A, it doesn't give you gravity. Let me set this back down to 0 first of all. And the second thing is that it doesn't expect a speed. It expects how many units of distance am I traveling this frame, which means our speed actually has to be multiplied by time.delta time. If you've done any Unity, you know what this variable is. This is the amount of time that has passed since the last frame was called. Update gets called once per frame, so time.delta time, and this means that if you have a computer that can run 1,000 frames per second, or you have a computer that runs at 30 frames per second, this means that no matter what, you will always be moving at the same speed on screen. You just, on one version, you're going to move smoother, and another one, it'll be a little bit more choppy, but you're going to cover the same distance in the same amount of time. So now that we've done that, everything is going to be great, except that we're going to be floating in the air, because move does not automatically feed us gravity. But I can walk around. I am anti-gravity man. Everything is great. We can see our world. It's beautiful. It's lovely. I love it. All right. So we want to feed gravity back into the system. And we do that, well, by changing a few things about our structure. Let me take a brief break here to drink some water and answer some questions. Feed me some questions, and I will drink this. Well, it's not water. It's Diet Pepsi. Yeah, 1,000 frames per second would be really easy to do. In fact, in this demo, if you've noticed in the top right corner, I get a stats counter. And it's currently saying, 60 to 70 frames per second. That's because in the current settings in here, it has it locked to the VSync. But if I turn that off, and I have no idea what this is going to do to the recording, but let's find out. If I turn off the VSync to don't sync and then hit play here, and look down, I'm currently running at somewhere between 800 and 1,200 frames per second. It's a very simple world. There's not a whole lot going on there. So It makes sense, but we're going to turn that back on. Any other questions? Well, Quill, if the degree was in fact -1, -2, -3, wouldn't that just be 360 -1, -2? It's not incorrect. That's an excellent question. It's not incorrect. The fact that -5 and 355 represent exactly the same sort of angle in terms of rotation, they're indistinguishable one to the other, is fine. The problem is, if I'm trying to clamp it, I'm saying I don't want to look up more than 60 degrees and down more than 60 degrees, and I query the system and it tells me I've been rotated 355 degrees. In my simple sort of math check, that's going to be well outside my range, so I'm going to autocorrect it entirely the wrong way. Whereas if it returned, if I'm saying from +60 to -60 and it tells me we're rotated -5, then all is hunky-dory and awesome. I could work around it by doing another check, by instead checking, am I between 0 and 60, or am I between 300 and 360, then that's a happy, acceptable range, and that would be fine. It's another way to work around it. It's just, it gets you, when you get that sudden jump from 0 to 359, a lot of times in your code, it's like, oh, that's not how I expected it to work. And quaternions do away with all that in a very beautiful, wonderful way if you're working them directly, but quaternion math is weird. This is not Let 'em Dare. Let 'em Dare is next week, and I can't actually participate in Let 'em Dare, so unfortunately, might do some more programming next week, but no actual Let 'em Dare. Yes, there's plans for Dwarf Fortress in the future, but I gotta stop answering video game questions. How can you easily edit the level? Like if you wanted to add knee height obstacles? Yes. So there's two ways of doing it. One, inside of Unity, Unity is a great, we're gonna call Unity sort of the scene editor. We can add more objects in it. We can move it around. I'm going to create a dummy, say, a cube in here, right? So this is just a cube. Let's scale it up to be a 2x2x2. Nice big cube. And then I can take this and I can move it around in my level. I can sort of put it down onto the ground and move it around. So that's great. And if I go into Blender and I make some cool looking object like a sofa, because sofas are great examples of cool objects, I could model a sofa in Blender, bring it into Unity, and then place the sofa here, and place another one there, and then place a TV object over here. And hey, I've got a living room, and how lovely. In terms of modifying the actual geometry here, like if I wanted to take one of these walls and round off one of the corners, you can't do that in Unity. You can't modify meshes in Unity. As a general rule, there's things, but let's ignore that. You can't modify meshes in Unity. You do your mesh modification in a modeling software like Blender or 3D Studio Max or Maya or countless others. But you place them, you arrange your scene, generally speaking, in Unity, and then you can do things like you can make the TV a physics object that you can actually knock over, not be static. You can make it so that when the couches get hit with bullets, they burst into flames. You handle that aspect in Unity. But the actual shape creation is done outside. Unity comes with a few sort of stock objects, the cube, sphere, cylinder, that you can use to do very basics. And a lot of times you could like lay out a scene with these cubes, then you're happy about the general shape of it. So, let's say we want to take this cube and we want to scale it more in the X. We're like, okay, that's a good sofa shape. So now I'm going to know these sorts of general dimensions, and I'll go into Blender and make something that sort of matches that. But yeah, and in terms of obstacles, where's our dude? Our dude is right here. I can take this and put it in here. Let's put a couple of obstacles so we can see what's going on. I'm going to create one box, and then I'll actually create another box in front of it, but bring it way, way down. Like so. And if I hit play, oh right, I forgot I'm anti-gravity man right now. Let me go and reset that. So we're going to go to the ground. Then when I hit play, right, I can see the objects, the cubes I've placed. One cube has to be sticking into the ground, but that's okay. They will block motion. I mean, they have collision boxes. The default cubes have collision boxes. I don't have to turn them on. And this one should be short enough that I think my step height will allow me to step onto the cube. Yeah. So it's basically a stair. Right? I can make a whole series of these. It needs to be stairs I can walk up. I could also take one of these cubes and turn it onto an angle. Let's do that with this one here. We are going to rotate it around the Z, like so, and then bring it down a little bit. All right, so now, if I go into this again, from here, I'm definitely, just bashing my head. Actually, that's mostly crotch level, which is entirely uncomfortable. But from this side, I should be able to walk up this ramp. The character controller deals with the, oh, right. So I walked up the ramp, and then when I jumped off the ramp, I'm not falling down. And the reason is that, again, we don't have gravity enabled. But other than that, the character controller handles all those collisions, and you can tweak all these parameters. Like if you don't want to be able to walk up these ramps, at least nothing this steep because of, I don't know, whatever, where, everything is ice and slippery, then you could change those modifiers in the character controller to control how high of a step you can walk up, how high of a slant you can walk up, all that kind of jazz. More questions? If you want to start off programming, there's great ideas. The link to Code Academy is awesome. You can also Google, it's like starting game programming with Python or something like that. It's a free ebook, and it is wonderful to teach you just the very basics of programming. Yeah, there should be more sofas in all FPS games. And yeah, jumping and re-implementing gravity is the next thing on our list. So let's get started with that. So let's do a quick save to our scene now that we've got some cool objects. So before we get to jumping, let's re-implement gravity. Very easy to do. Oh yeah, I remember that's where I got left off. The thing with gravity is, well, to start off with, we could just implement gravity right here as the Y component of our speed. Let's get started with that. So we can put in anything we want in here. We can just say gravity is -10, or it's 9.87. Whatever gravity is supposed to be. You know what? I don't remember what gravity is. Luckily, the physics simulation is already set up with gravity. Let me show you. Let me set that back up to 0. Let us, let's create a sphere. We'll show you that gravity is all set up inside of Unity. Unity's physics system is, what am I looking for? Create other. Create a sphere. We're going to take it. We're going to set it on top of the ramp. Let's bring it down a little bit. Right around there. So if we hit play, this ball, which is set up to be, it's got a sphere collider, we're just going to add a physics component. I know this is kind of fast, I'm not really explaining. This is not the point of this particular game. I'm just demonstrating the fact that physics is enabled. I hit play, the ball will roll down the ramp, bump against the wall, and then come to a stop. Physics! It works. It's there. So the physics engine knows what gravity should be. And in fact, if I go into Edit, and I go into Project Settings, and I go to Physics, you can see that gravity's set there at 9.81. Damn. Is already set up for us. And you know what? That's a great place for it to be. Why on earth would we hard code in gravity? Well, I can tell you one reason here. For some reason, we might want our character to fall at a different rate from everything else in the world. Maybe he's got, anti-gravity boots, so he sort of drifts down. He's got one of those Mario capes, right? So he just sort of drifts down. There's lots of reasons. So we can use the existing physics gravity like so. All right, we're going to feed that into our Y speed, and I believe, gravity is a vector because you'll notice over here, I can actually set the gravity to work in different directions. Right now it's going straight down, but it could be angled, it could be going different things. It could be going in different directions for different reasons. In fact, in my pinball game, rather than tilt the table and have to deal with everything in the game world being tilted while I'm trying to place it, I lay everything flat, and instead I change the gravity vector so that gravity is going slightly sideways, so that effectively it's the same as if the table were tilted. But it means that gravity is a vector, so we only want the Y component of gravity here. Because why not? So now, if we take our player and send him into the sky again, we are going to fall. Boom! All right. Now, we are not actually, it's not real gravity at this point because we're not actually accelerating. We are moving downwards at a constant speed of 9.81 meters, which is not how gravity works. Gravity, if you remember high school physics, gravity is an acceleration. It's 9.81 meters per second squared. We need to be accelerating downwards. So the longer you're falling, the faster you go. This is not what is happening here. And it requires that we change things somewhat in that we actually persist our speed over the frames. So we're going to have to step back and kind of re-engineer some of this a tiny little bit. Yeah. Especially because let's say we want to jump, right? So we've got some sort of like if we're jumping, whatever that code is, okay? We want to set the sort of y component of our speed, and speed dot y, god damn you, speed dot y is equal to whatever our jump speed is, which is 20. Great, we're going to jump at a speed of 20 up in the air, which is going to be awesome. And then what are we going to do? Like override it with the no, this doesn't work. You're going to see, if you try it yourself, you're going to see it's quite obvious that it doesn't work. So we actually have to have a new sort of bookkeeping vector over here, which we're going to call our velocity. And it's going to default to vector 3.0. So by default, our velocity is nothing. And so we don't want the speed thing anymore. Instead, our velocity, which I could have just called speed, but velocity is more physicsy and accurate. Our velocity we are going to set a couple of different ways I can do this. Actually, hold on. Let me back out of here. Let's not make our life this complicated. Just erase the last 2 minutes from your brain. We don't need to keep track of our velocity overall. All we need to know is our vertical velocity. That's what's important that we maintain from frame to frame. Because really, the vertical velocity, is the only thing that's kind of remotely physics-based in here. Our forward, back, and left, right motion is completely unphysics-oriented. So we can reset it every frame exactly. But the vertical velocity is going to work a little bit differently. So over here, we're not going to feed the gravity right in here because you know it's wrong. We're going to feed our vertical velocity. But our vertical velocity is going to be accelerated by the gravity's y every frame, but because it's an acceleration, we need to multiply it by the time.delta time. I'm sure this isn't sinking in for a lot of people, but you'll just have to trust me. Because this is an acceleration, we can't just add the full gravity every frame, because again, if you're running at 1,000 frames per second and you're adding 9.81 to your velocity every frame, you're going to hit warp speed before you know it. So you have to do that. So now we will accurately accelerate by 9.81 every second. Feed it into there. So vertical velocity is going to grow and grow and grow and grow and grow, and that's going to be perfect. If we hit play, again, we should drop. We drop slowly at first, but when we drop faster and faster, and that would become even more obvious if I set myself up at like 1,000 units above the playfield. Right? So I'm very high up, I'm slowly falling, but I should be going faster and faster and faster. I started really high, and it's coming in on screen now. Maybe I should have set it to 100. And now we're falling very fast, boom, left a crater. All right. Downward acceleration, working great. So how does jumping work? Well, jumping is going to override the vertical velocity and send us upwards. So there's already a key defined for jump. It's bound to space by default. So if we check our inputs, we can see there's a jump here. It's bound to space. Great. So we are going to check if the jump key was pushed down. So if input.getButton, well, let's talk about getButton first. If I go getButton jump, this will return true every frame while we hold the spacebar down. Which, if you're doing something like a bunny hopping, if you can just hold space and it'll just like bounce, 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 bounce. That's what you want. If you want it to work like most games work, which is every time you actually hit the button, it jumps, this is what you want to do. This is asking, did the jump button go down since the last frame, basically. So this will only return true once. If you're holding down space, it'll only fire the one time, and that's it. And then if we are jumping, we're going to want to set our vertical velocity to be equal to our, say we'll call it jump speed. and we are going to public float jump speed. We're going to set it to a 20, which is quite a high jump, I believe. And this should, let's reset ourselves down to 0, so we start on the ground. And jump. All right, yep, that's a pretty high jump. But we are now jumping. And I don't mind the height here for testing. Now, one of the interesting things that's going to happen is I'm going to hit space to jump, and then when I'm in the air, I'm going to hit space again. And again, and again, and again, and again, 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 again. And I'm also going to move forward and sideways and backwards. I'm going to hit jump again. So now we're not really jumping so much as activating like rocket boots or something like that, right? So obviously, the problem is that at no point in this are we checking to see, are we actually on the ground? Because unless, again, we're using rocket boots, you should not be able to jump if you're not on the ground. Let me change the jump height. I'm going to draw, or this is not jump height, this is jump speed. It doesn't convert to height directly, but I'm going to drop the speed by half to about 10. And I think that's going to be well, it's actually still a pretty ridiculous jump height. Let's try 5. I almost think that's not enough, but we'll leave it. Yeah, you know what? Set it to 7, split the difference, call it good. Okay, so we want to check to see if we're on the ground before we jump. It also leads to another huge question. Should we be able to steer ourselves in the air? Because, okay, so there's a very simple check we can use. We can do something like if. This is using our character controller, which we're gonna take this call and move it to the top of our update function. So we're gonna grab our character controller. We're gonna move it somewhere else entirely pretty soon. If our character controller is grounded, that's it. Is grounded is true if we're touching the ground, and it's false otherwise. Great. So do we wrap our entire movement code around it, or do we not? Personally, I think most people expect you to be able to sort of move yourself while you're in the air. I mean, Super Mario Brothers and first-person shooters and all these games, most things give you some amount of air control, even though it makes no physical sense whatsoever. So we're gonna allow it, but we're not gonna allow you to double jump or infinite jump in the air. And you could, right? If you can double jump, then you can set a thing. Every time you jump from the ground, reset your double jump to be, false. Your has done a double jump to be false. And then if you hit jump again, you're not grounded, but has double jumped is set to false. Then we'll allow a second jump, but then set has double jump to be true so that you can't, do it infinitely or something like that. You can easily do that. We're going to do it this way. So now I believe that we can jump once. Yep. And then if I hit jump again in the air, nothing happens. I can keep tapping it and keep jumping it. That's fine. But then in the air, I can move myself around. In fact, wow, we're moving fast. Well, here's an idea. You could do something where if you are not grounded, you can still have air control, but maybe only half speed. But this feels kind of like a first-person shooter, like the more actiony ones, where you're in the air and you're like juking in the air and doing ridiculous things. Actually, it feels quite acrobatic. I like it. It feels good. Let's go up here. Oh, here's something some people may be wondering. This ball, I can run into it, but I can't actually move it. So character controllers can collide with objects, and objects can collide with them. If that ball was rolling towards me, it would bounce off of me. But a character controller that slams into something does not trigger the normal physics collision code, because again, we are an inherently non-physical object. It doesn't know how to deal with that. So we would actually have to explicitly do a thing where if our character controller has collided with something and it's got a rigid body like this ball, then sort of artificially give it a shove. We actually have to program that in. And that's not unique to Unity. That's not like a weakness of Unity. That's just sort of the reality of how character controllers work. From the top of this ramp, we should be able to jump on top of our level geometry. Awesome. And then we can throw ourselves off the cliff. Yeah! We're falling faster and faster. Awesome. Movement. And quite compelling movement. It's feeling good. How much work did we actually do here? I mean, there's a fair amount of code here, but we could probably cut this code down by half if we wanted to and still have all the same functionality, and frankly it might even look better. One of the things I want to clean up, the character controller, we are picking it up on every single frame, and this is technically kind of an inefficient thing to do. It's not really hurting us here, and you don't want to optimize too early because you just go out of your way, but this is actually kind of a silly thing. What we want to do is grab it once and be done with it. Furthermore, it'd also be a good idea if we actually checked to make sure there was actually a character controller on our character. So one thing we're going to do, we're going to take character